So just a couple of extra examples here. First off, looking at here example 1, we have y equals log 2x. Please be careful. What is the base of this? 10. Thank you. This is the common log. It is not written as a base. Don't think that this is base 2 of x. It is not. If I wanted it to be base 2 of x, then I would have written log base 2 of x. That's why we have to be careful how we write our notation. Okay? A lot of you guys get kind of sloppy with writing your bases and writing your exponents. Okay? We got to watch out for that because it means something totally different depending on how you write it. Okay? So, we have log base 10 of 2x. That is kind of grouped together.
So whenever it's just log, you just automatically...
It's called the common log, and it's base 10. Yep. All right. So just as we've done before, the first thing we need to do is rewrite it using the rule. Okay? Now, I've got the rule over on the board for you to remind you of it. But remember now that 2x is grouped together. Okay? That 2x is grouped together now. So we're going to have 10 to the y power equals 2x. Okay? That's how we rewrote that now in exponential form. 10 to the y power equals 2x. But we know that when we plug in, first off, when we plug in for logs, when we're graphing logs, do we plug in plot points for the x or the y? The y. We plug into the y because that's the exponent. It's just easier that way, right? So, but I want to solve for x. So I know I'm going to have to do something with that 2 to solve for x. So how am I going to get x by itself? Let's just do that part now. Divide by 2. Okay. So we're going to run into a problem here, though, because when I start plotting points, I use -2, -1, 0, 1, and 2. If I plug in -2 for y, what is 10 to the -2 power? 1/100th. 1 over 100. Oh man, but now I got to take that and divide it by 2. Is it easy to take fractions involved in fractions? No. In fact, we don't do it, right? We try as hard as we can not to do that. So how would I rewrite this so that I'm not dividing by 2? Have we ever divided by a fraction? No. What do we do instead? Multiply by the reciprocal. So don't divide by 2. Multiply by 1/2. So we want 1/2 times 10 to the y, and that's going to equal x. And so now we can take 1/100th times 1/2, which gives us what? One 1/100th times 1/2. Please think back to your elementary skills of how to multiply fractions. 1 over 200. 1 over 200. 1/200th is what we get. All right, well, let's keep going here. What is 10 to the -1 power? 1/10. What is 1/2 times 1/10? 1/20th. What's 10 to the 0? 1 times 1/2. What's 10 to the first? 10 times 1/2. What's 10 squared? 100 times 1/2. Any questions on how we did that? Okay, we okay getting those values? All right. So now we got to go through and graph this. Now please remember, we didn't shift anything here, right? We had no shift involved. So our asymptote is still the y-axis. All right? And when I go through and graph this, I can't graph 1/200th. Okay? I can't graph 1/20th. But I can graph 1/2. Make sure you're paying close attention to what the x coordinate is.
Did Bryn come to the office?
Pay close attention to what the x coordinate is and what the y coordinate is. Okay? So this first one I'm going to graph is 1/2, 0. So 1/2, 0 brings me here. 1/2 on the x, 0 on the y. 5, 1. Brings me here. And again, sadly, I can't graph 52. Okay? So we have 2 points. But that's okay, because we should know what this graph looks like. Okay? We should know that our logarithmic graphs always look like that, right? So we need to make ours look like that, even though we've only got 2 points to work with. All right, so I'm going to start down here. It's going to go along that asymptote until we just start to turn real fast. And it's going to go up like that. Okay? Questions? Please be careful when you're graphing these. On your quizzes, I took points off because some of you were graphing your exponentials and you were making your graphs. Now, of course, this is for a logarithm, but you get the same idea. You were making your graphs kind of go up over the asymptote like that. That is wrong. Okay? It goes straight along that asymptote. It keeps getting closer and closer and closer, but never touching. It's never going to curl back up. So pay close attention, folks. That's an attention to detail thing. That is a don't be sloppy type situation. Okay? All right. Any questions on example 1? No? Then let's take a look at example 2. In example 2, we have log base 2 of 4x. All right, well, again, this is that same type of situation. We have log base 2 of 4x. The 4x stays together. Okay, so what are we going to do first? Rewrite it. Anybody have? 2 to the y power equals 4x. Okay. Well, next, I want to solve for x. It's just easier to do it now rather than later. So what do I do next? Okay, I could divide by 4. I heard somebody say multiply. Multiply by 1/4 does the same thing. If I multiply by 1/4 on both sides, the 4 and the 1/4 cancel, and we get x equals 1/4 times 2 to the y power. Okay, now if we had wanted to, we could have gotten real fancy here and tried to rewrite 1/4 as 2 to the negative 2 power, and then said, okay, well, I've got the same base, so I multiply or add the exponents and end up getting 2 to the y minus 2 power. We could do it that way, but I think it's getting a little bit more complex, a little fancier than what we really need to do to finish the problem. Okay, so just multiply by 1/4 will be fine. Well, now we need to go ahead and plot points. So we plug values in for y. And what is 2 to the negative 2 power? 1/4. And what's 1/4 times 1/4? 1/16. What's 2 to the negative 1? 1/2. 1/2 times 1/4? 1/8. 2 to the 0. 1 times 1/4. 2 to the 1. 2. 2 times 1/4. And 2 squared. 4. 4 times 1/4? 1. All right. So, again, plotting these points. Again, we don't have a shift, so our asymptote stays the y-axis. I'm not going to be able to plot 1/16. I'm really not going to be able to plot 1/8, but I can do my best at plotting 1/4 0. So 1/4 0 is going to be right about there. 1/2 1. Again, pay close attention to which one's the x-coordinate, which one's the y-coordinate. And then 1, 2 goes there. All right. So here's the issue I'm having with some of you on your quiz that we had gotten back. is when you're graphing this, you do all this perfect. You even do the part with the asymptote. Some of you do that perfect. Where you come down here and say, all right, so this is this part of my graph, the tail, it's going along that asymptote. And now I got to go through those 3 points, and then all of a sudden it goes over this way. That's wrong, folks. That's wrong. Okay? Because if you look back, if I'm able to erase this, if you look back at those 3 points, I'll leave it there. Can you kind of eyeball and see a curve that's happening with those 3 points? I'm hoping you can. And has that curve become a really sharp curve? No, it's a real gradual kind of curve, right? It's a real gradual curve. So when you're doing that, make sure that you're drawing this as if it's a nice, real gradual curve. Okay? And in fact, I think I went a little low on that. Okay? If you want, go ahead and plot more points. It's not that difficult. Plot more points. We stopped at 2. What if y was 3? What's 2 to the 3rd power? 8 times 1/4. What's 2 to the 4th power? 16 times 1/4. 4. What's 2 to the 5th power? 32 times 1/4. So we have points at 2, 3. We have points at 4, 4. See, I knew I went a little low. And we have points at 8, 5. Okay? So this should have gone up like that. Okay, but again, the big point being is that there's not that drastic turn right at that last point. A lot of you are doing that. As soon as you go through your last point you plotted, all of a sudden the thing goes vertical or the thing goes horizontal. Okay? It doesn't do that. It continues on that curve very gradually going up. So if you would like to, there is nothing wrong with plotting a couple of extra points so that you have points to go through as you're drawing your graph. Okay? Questions?